Hello, welcome to another problem session. Today we are going to talk about kinetic friction. This is a problem that requires a lot of description for setup. So you should read this carefully and make a note of the situation. So let's work together and see how I look at it. So it's about this book here. This is the system, and when you're sitting on the table, so I'd say there is some time zero. It's at rest. V equal to 0. Then I push on it and with increasing force. And when the force is beyond 25 Newton, this start to slide. So say I went to say if I apply more than 25 Newton. So this if then this start to slide. So you can say that this let's see table is very long, and clearly it was V equal to 0, and this is V not equal to 0. So it slides. So all this time acceleration is 0, but while keeping the direction same, you reduce the force. So it has a V, and you reduce force, and you just maintain V now. Maintain V constant. So over here is sliding at constant velocity and by F, which is still at 30 degrees. But it's not accelerating. It's going V constant and acceleration equal to 0. So it is this situation that we're supposed to analyze. All of these are just to get to this situation. So it says when it's a constant velocity, then what is the magnitude of this applied force F? All right, this means that at this instant, so some instant t, this is happening. At this instant, all the forces on the book are balanced, right? So at this instant, sum of all the forces on book equal to 0. So this kind of problem, since acceleration equal to 0. So this kind of problem, we usually do it by you identify forces and you do free body diagram, and then you do all the x equal to 0, that's one equation, and all the y added up equal to 0. And if you had a third dimension, you'd have a fz equal to 0. But we are really deal with that in this elementary problems. Okay, so all this, so these two equations will have sufficient information to get the answer. All right. Third thing we need to know here, we have is a sliding. So book and table, and the book, this surface is not constant, it's sliding. So there will be a If it's moving in that way, then opposite of that will be kinetic friction. Kinetic friction. And kinetic friction is also related to normal force in this manner. Okay, so so let's follow this steps and see what we come up with. First step is identify forces. So you have a weight, which is equals to mg, and we can say g equals to 10 meter per second square. So here it's just a 15.0, like 15.0 Newton, 15 or 50 Newton, just 50 Newton. Okay, and that's the weight. We already talked about friction, Fk, and we have normal, and we have this unknown force to maintain this constant velocity. So these are the 1, 2, 3, 4 forces, and we can write this equal to mu k Fn. So mu k is given, which is this value. So it turns out to be there's between these two there's only one unknown, and then there's F is unknown. So there's only two unknowns, and we'll get two equations, and so we have sufficient information to complete the problem. So writing this as a free body diagram is all forces coming out of a single point. So we draw it like that. So let's look at this. So we will have 15 Newton, and we'll have a force which is unknown amount, but this is 30 degrees, and we have a normal force, and we have 0.3 Fn. Okay, from this let's call this x-axis and call this y-axis. So the x equation will be the F, and this will be cosine 30 degrees, F cosine 30 degrees, and this will be plus because the projection is on the positive x-axis, and this one has nothing, this one has nothing along the x, and this is along the x is negative, minus 0.3 Fn equal to 0. All right, let's do the y. F has y, which is negative, minus F sine 30 degrees. Why is it negative? Because when I project on it, I hit the negative y-axis, and then I have a 15 Newton, and then I have a plus Fn equal to 0. Note Fn is not mg. Okay, so this, you should never assume what Fn is. This is one of major sources of error for beginning students. Here Fn will be found from these equations. Always Fn will be found from whatever the equation requires. Okay, so that if I eliminate Fn from here, all I have to do is multiply this by 0.3 and then add these two steps, add the two equations, will get me there. So F is square root 3 over 2, and this is plus 0.3 over 2, that's times F, these two, and then this will kill this, and this will be minus 15 times 0. Plus 15 times 0. I'm adding, so equal to 0. I'm adding, so this will be negative. Okay, so clearly we got the F is equals to 4.5, and this will be square root of 3 minus 0.3, and this is going to be times 2. So that's the answer. And if you want to get a normal force, we can just plug in here and get the normal force, or plug in here, either one of the two, you get a normal force. Okay, so you can use calculator to complete this work. I will leave the answer after I pause it. So this calculation gives me 6.3 Newton. Okay, next we're going to do a problem involving kinetic friction, where it's not constant velocity. For instance, this situation where the acceleration is non-zero but sliding. We'll do that in another video. So talk to you later. Bye.